Hello again, we're dividing polynomials. It's not a very fun subject for students. This method that I'm going to show you works for dividing all sorts of polynomials, one polynomial divided by another. There are other forms you can use. You can use factoring, which is actually very quick in comparison when you're doing some types of problems, but students don't like that. And there's synthetic division, which students like, but you can't use it on most problems. And then there's this method, old-fashioned dividing, which I think is really cool. And sometimes students ask, what are we even learning this stuff for? It's so boring, or it's so useless. Well, I don't think it's useless. What we use this for is to help ascertain what a graph looks like. It's really cool, actually. You can figure out horizontal asymptotes versus vertical asymptotes, but that's a little bit ahead. I'm being ambitious here. And then students will say, oh, you always think this math is fun, even when it's boring. And maybe that's true, maybe it's not, but I say, it's not that I necessarily think it's fun or boring, it's that, we do something and it's challenging, and if you're able to go over the challenge and you're able to do it nicely, you kind of feel like you accomplished something. That's kind of why I like math too, I can do something good. Makes me feel better. Anyways, so I've got this expression, or this polynomial, divided by another polynomial, monomial to be more specific, and it reads 4x cubed plus 8x squared plus 10x divided by 2x. Well, what I want to do is take the first expression and put it on the inside, and I divide it by the outwards expression, which is 2x. So here we go. All divided by 2x. Now, students can have trouble with this, and I've noticed the years I keep teaching, you got to kind of switch it up a little bit because students don't necessarily understand it the same way they're used to. And I say, well, 2x times what number is 4x cubed? Just baffles them. They're like, I don't know what you're talking about. I'm like, okay, think about it this way instead. What you got to do is take this term and divide it by this term. And they say, well, why this term? And I say, because you got to put something over the 4x cubed. So we're going to take this one. And then once you have something over the 4x cubed, then it's the next term divided by 2x. Or whatever there's nothing on top of. So here we go. 4x cubed divided by 2x is, I can get out of your way there, 4 divided by 2 is 2, and x cubed divided by x to the first is x squared. That's basically it. That's all you do. 2 times 2 is 4, x squared times x to the first is x cubed. Now, back to those other examples we did, 400 divided by 5, 400 divided by 6, you change the sign. If it's negative, you make it positive. If it's positive, you make it negative. And this was positive, so make it negative. 4x cubed, subtract 4x cubed, bam, drop the next one like a bad habit. 2x, how many 2x's fit into 8x squared? Well, what you can do is take 8x squared and divide by 2x, and then you'll figure that out. 8 divided by 2 is 4, positive 4, so it goes on top of there, the 8x squared, and x squared divided by x to the first is x. There you go. We're not done. Don't think we're done. 4x times 2x is 8x squared. Switch the sign, cancel, drop the next one down, which is 10x. How many 2x's fit into 10x? We take 10x divided by 2x. 10 divided by 2 is positive 5. You have to note if it's positive or negative. And x divided by x is just 1. So it's just 5. 5 times 2x is 10x. Switch the sign. Oh, yes! Remainder is 0. No problem there. So my answer, if somebody asks you, what's 4x cubed plus 8x squared plus 10x divided by 2x? You can look at them in the face and say, I know the answer. It's 2x squared plus 4x plus 5. You probably will never have to answer that question to anybody in real life outside of a math class, but you never know. Next problem, I have 4m squared plus 13 divided by negative 1 plus 2m. Okay, here we go. When you're dividing polynomial expressions by another polynomial expression, you want to make sure they're both in standard form, i.e. from highest degree to lowest degree. Well, this one's fine. The m squared goes first and the 13, bam. But there's no m term in between. We got to work on that. And this one should be 2m minus 1. It's not a big deal, but make sure 2m subtract 1. You want to go from highest degree to lowest degree. You want to put it in standard form. So the first one goes on the inside. Gonna have to get rid of that marker. 4m squared, but we don't have a term in the middle. And yes, we do need a placeholder. So since there's no m term, we're going to put 0m, because 0 times m is just 0, and then plus 13. Now you'll see why momentarily. You can divide by 2m, subtract 1. This one's garbage. Guess I got these two. Okay. What I want to do is take the first term and see how many times it fits into the first term here. Well, so I've got, how many 2m's are going to fit into 4m squared? If you don't know that off the top of your head, take 4m squared and divide it by 2m. That's what I tell my students to do who don't get it right away. 4 divided by 2 is 2. Okay. M squared divided by m to the first is m. Here's the tricky part. You take 2m times 2m, which is 4m squared. You take 2m times negative 1, which a lot of students will forget, and that's negative 2m. Now, you're going to take the difference of both of them, but that's tricky for students. This was a positive, so you make it a negative, and this was a negative, so you make it a positive. 0 monkeys plus 2 monkeys is 2 monkeys, and then you drop the next term, which is plus 13. Now you want to figure out how many 2m's fit into 2m's. Well, that's not a joke. You take 2m over 2m. It's not 0. 2m divided by 2m is 1. It's positive 1. So you go ahead and you put that there, plus 1. And you got 1 times 2m, which is 2m. You got 1 times negative 1, which is negative 1. Switch the signs. No more monkeys jumping on the bed. That's actually really clever, and I don't think anybody's going to laugh at that one. And then you got 13 plus 1, which is 14. So my answer is, well, I have a remainder of 14, and I don't have any other terms to drop afterwards, so I'm done. So my answer is 2m plus 1, which is right here. Then it's a remainder 14 over 2m subtract 1. That's it. That's an introduction into dividing polynomials. I'll show you a case of synthetic division, not because I think it's very simple for students, but rather because I want to show where students make mistakes so they don't want to get over-reliant on synthetic division, because it only works for a few types of problems. It doesn't work for all types of problems. And with that in mind, we'll do that lesson next, but have a good day for now. Goodbye.